I got a small project I want to do this morning. This is a Noga arm that I've had, and I use it to hold my camera. The problem is I've never actually had the proper adapter to be able to hold this to a mag base there, so I've just always clamped this like in a little vise or something. Kind of getting tired of doing that, so I'm going to machine an adapter that's going to go from M8 to M10 for this Noga magnet right here. So this was one that a viewer had given me a few years ago, and so we're going to mount this right there on that magnet. So this is a mount that I'll use with my phone right here, and this is a pretty handy little clamp that I'll just go just like this. I just clamp it right there onto the phone case very lightly, and it holds it perfectly. And then having the articulating arm to be able to move the camera around where I want to. So that's what we're going to do. So I was able to use my no-go gauges right here to determine the pitch. So we have an 8, an M8 right there, and M8 by 1.25, and then this guy right here is an M10. All right, I do not have any of the OD thread go gauges, so I'll just use some regular hex nuts to just determine the size. And got a piece of material right here, so we'll go to the lathe and get started on it. Let's go ahead and start turning this thing down. I'm not sure what that material is, but my guess is that it's just 1018 cold rolled steel. Whenever I'm machining this adapter, I'm going to want to put a nice big fat corner radius in there where it transitions to the larger diameter. So I want to use my top notch insert right here. I've got a few different inserts with different radiuses there. But this being a 1-inch shank will not work on my machines. I need to use a 3/4 shank because I need to lower. You can hold this in my tool holders, but with a 1-inch shank, I cannot drop the center height of the tool down to the center height of the spindle there. So I have to remove a 1/4 inch off the bottom of these tools so that I can lower it down to the proper center height. So we're going to do that before we actually get started so that this is ready to go whenever I get to that op. And we're going to use the shaper to do that because it's always fun to cut these on a shaper. Just going right up to that shoulder right there. So looks like it did pretty good. Going back in for the second cut here. So we'll use our tool that we just modified. It's got a 1/4 inch wide top notch insert, so it's a 1/8 radius is what we're cutting there. I just want to blend this in down to the bottom down there. Kind of got ahead of myself and put the radius where I actually didn't want it right there. We're going to have a step that's going to, let me just show you. So this diameter right here, which is like 14 millimeter, we're going to have this where it screws down to this face right there and kind of match that diameter, and then we'll have a radius past that going up to where the hex is going to be. So I'm going to remove that radius there, and we're just going to make an undercut for the threads. Now we can go ahead and cut our large radius in there. That'll blend it all together. I just got through reconfiguring the quadrant gears here so that I can cut metric pitch over here on the lathe. So it's pretty simple on this Victor lathe. So you're normally running 25 and 50, 25 up here, 50 down here, and depending on what pitch you have to cut on metric, it gives you which gear you have to put on the top there. So in this case we're cutting a 1.25, so the A gear, which is at the top, is a 50. That's up here, so we got a 50 there, and then down here it's a constant, which is a 70. So we got the 70 there. It's normally the 50 is here and the 25 is up here at the top. So it's a pretty simple change there. And then since we're going to be cutting both sides of that thing is a 1.25 pitch, so I'm just going to leave this set up until I'm through with the job, and then I'll put it back on where it needs to be. All right. All right, we're ready to start cutting these threads. So with this being a metric pitch on an Imperial machine, this is one of those situations where you're not supposed to disengage the half nuts. You can disengage, which is the technique that I now use for cutting metric thread. So I'll show you how I do that. But once we engage on the half nuts, that particular position is where we will always engage the half nuts at. Okay, so let's go ahead and make our scratch pass. All right, I didn't disengage right there. I just backed out, and let me come back in here. Let's do that again, like I normally do. We're going to come through here, disengage the half nuts. All right, we're going to back our tool out. I'm going to reverse the spindle and engage the half nuts again. And that's going to put us right back where we need to. I'll come right back into my 0 and we'll prove it. Make sure we're not cross threading. Looks good. Back the tool out, reverse the spindle, engage the half nuts again. I'll go ahead and give you guys a shot of what I'm talking about here. So there's my threading dial, and what I like to do is I like to keep a paint mark on one specific number. In this case I actually use 1. I usually use yellow, but my yellow paint marker is dried up, so I had to use blue. Okay, I've also got a dot on the housing there of where this thing actually lines up. This little drive pin there is actually supposed to be the location, but you can see where it's off just a little bit. Alright, so I'm going to go ahead and reverse it, and just going to bring the tool out a little ways so that I can show you what I'm talking about here. I don't have to worry about crashing it. So now we're going to act like we're threading it. We're going forward, and I get down to my thread relief. I'm going to go ahead and back the tool out, disengage it, and you can see the gauge, the dial coming around. Stop the machine, reverse the machine, never lose place of where this position is at. Engage it. Alright, stop the spindle, bring your tool back into your 0 or however you decide that you want to do your end feed, and now you're ready to make another cut. Go forward. So as long as you don't lose place of where this original engagement position is when you first start, you'll always line back up on your pitch. Disengage, stop the machine, go in reverse, and then let the tool back out to clear your threads. When you're through, stop it. We're going to run our tool back into our 0. I got a 0 here and a dial indicator up there, and now we're ready to go and start another thread. Start another cut, I mean. Let's go ahead and get started. We'll do a 10 feed. I'm using the compound end feed on the compound here. Once you get a rhythm going, nothing to it. Alright, I'm just using a regular hardware grade hex nut here. This is one I have in my set to check the threads, and I did use this. I used the go gauge and it fits this nut perfectly. So we've got a good fit right there on our nut. So this should work just like it is, and we'll check it with the articulating arm adapter at the end. We'll screw it on there now and see. Alright, there's our piece that we want it to screw into. Looks like it's got a good fit on those threads. Alright, that'll work. I'm going to use my Metal Devil saw here to cut this piece where I want. It's going to be a great saw for that. We've got these V-jaws in there that'll hold this thing right where I want it. And we're just about there, right where I had it there. I'm just going to give myself about 1 inch in this area right there where we're going to cut our 10mm thread, and then have enough room to be able to hold it, and then just mill a couple flats on there for a wrench. So that's about 1 1/16 inches right there. Got a nice cool cut. Our piece is landing back here in the chip pan. There we go. So we're going to be turning about a 1/4 inch back and threading. This is going to be a real short stubby thread. So this jaw right here, the 6-jaw chuck, should provide some good even clamping force on that little short piece of material there. Looks good. That'll be our thread length right there. There's not much going into that magnet. We'll get this turned down to 10 millimeter. Alright, I went ahead and slowed it down this time so that I don't have to worry about crashing into that shoulder. You can see how close that gets. Checking the pitch there. We're right. There we go. That last little couple thousandths I just took. Looks like that was the ticket. Good fit on the nut. Let me go grab the magnet and we'll check that. You can see it's a very shallow hole there in the magnet. I gave myself just a little clearance so it wouldn't hit the bottom. Looks like that's going to work great. Alright, just need to file those threads and then we need to go to the mill a couple flats on it. Alright, I'm just going to manually cut in a couple of wrench flats on this thing over here in the K&T. We'll touch off and I'll just move it down a certain amount, cut across, and then we'll flip it over and put one on the other side. That's a 1/2 inch high-speed cutter, by the way. looks pretty good, just like it is. I think that's going to give us plenty of wrench flat there to work off of. Just take it out, flip it 180 degrees, and I just used my scale flat like this up against the side of the jaw, just to line it up on the end of the collet block. Just as simple as that. So should be able to use a 7/8 wrench there to tighten it up. Perfect. That'll work. Just need to file these off and deburr it, and we'll be ready to install. There's our deburred adapter. "12mm wrench. It fits that flap very closely. I think we got just enough room to tighten that up. Yep. All right, there we go. So now we can use our articulating Noga arm with our clamp, and much easier to be able to use this to hold my phone. Let me go grab that. I'll show you how I hold it. So it's usually about like so whenever I'm using it, and I take my phone and I usually clamp this bottom corner right about there in these blocks, and I don't clamp it very hard, just enough to hold the phone. This is one of those OtterBox cases, so it protects the phone pretty good, but you can put just enough clamp pressure on there, and see, now I have a completely articulating arm that if I want to use this to take a picture, or I use it for videos a lot, really good for close-up pictures if it's not on a machine. If it's over on a machine, it vibrates too much, but this is super handy. You can stand it up if you want to do the vertical style of photographs, but that'll work really nice if I want to get in there and let's see. So I want to get in there and take a video. Holds my phone right where I need it. You can see what I'm talking about, that vibration with the iPhone. It doesn't have stabilization in there like the GoPro does, but position it right where you want it and take your video or take your photo. Get in there and take your picture the way you want. So just another little helpful tool that'll help me keep creating the content around here for you. I always make use of my phone. It's an excellent camera. So there we go. I was happy to get that little guy done. So I went to grab my Sure Shot to be able to use it to clean some cutting oil off, and it was empty, of course. It's always empty. So anyway, I needed to fill it up. So I got a red can that I used to fill that up, but my red can was empty. So I went to go grab my big can to fill my red can up, And the red can's always a pain in the butt to fill up because it's got that safety, you know, it's got this lid on there that it doesn't really allow you to keep a funnel on there without it just trying to push it off there. So I keep it pulled back, and I made first use of my Noga clamp to be able to hold the funnel right here. Actually, I used the reed vise to hold the can, and then I used the Noga arm there with the clamp to hold the funnel in place, and it worked beautifully. So I got that set up to fill it up from this can there, and I just thought that was really funny and just kind of goofy, and I thought I would share it with you guys. So anyway, first use of the clamp there.